Hi there, welcome back. Welcome back to the second video in the Telefunken Dacapo restoration series. Since the first video, I've done quite a bit, starting with cleaning. Obviously, I had to remove that blanket layer of dust that this thing was being protected by. And I say that with intent. This thing was really protected by that dust. There is absolutely no rust, no major grime, nothing like that on this radio. It's amazing. It's actually incredibly clean. I'll show you in a second. After that, I got down to a lot more work, starting with the actual power supply, which I mentioned before. I always go power supply and then audio and then radio. So I check the power supply. I know the power supply transformer is working, the power transformer is working because we switched it on, right? We didn't get much. It was very muffled, but it was coming on. So the power transformer was good and the audio transformer was good. That's always a good place to start. Then, what else did I do? Oh, first things first, before I went any further, I put this thing on 240 volt setting. We have it at the back, which is a good thing so that you don't feed it with unnecessarily high voltages. So we set it to 240 volt. It's a bonus that this thing's got that setting. All you need to do is put in a coin and twist. Then I went on to the actual filter capacitors. I always change them. Sometimes I put them on the underside by removing the dual cap. This thing's got a dual capacitor. I sometimes put it on the underside. I sometimes restuff it. And in this particular case, I decided to restuff it. Now, let me go one step at a time. Let me show you what this thing looks like now. Now, disregard those yellow caps for now. I'll explain to you what I've done there. But look how this thing came out. It cleaned up absolutely beautifully. And I had very little work here. I used a bit of isopropyl alcohol with a brush. It's a natural brush and then cotton swabs. Isopropyl alcohol always works best for me because it leaves no residue. And the result is pretty good. You can see that all the metal is clear. There's no rust at all. I've not cleaned any of the piano keys yet. I've got to leave some cleaning for later. Yeah. Okay, let's look at what has been done on here in detail. What you're seeing here is not the original filter capacitor. Well, it is the original filter capacitor, but it's gone through quite a few modifications. It's had its guts removed. And the way I do that is actually quite simple. I've shown before how I go about it. First of all, just take a photo of the underside to make sure you know how this thing is fitted. So with the pliers, you twist off those clamps and this thing comes off the top. And then what I do is I remove it completely. And while this thing is in that state, take advantage of the clearance and do some cleaning in that spot. And then I rip out the guts, and I've shown this before in detail. There's a video in my building block series, which I'll link above, that shows you exactly how I go about doing this. Take out the guts completely and then bring in two new capacitors. I will solder them together and then put them one on top of the other and get this thing ready to go back into the case. And once it's back in the case, you twist it back closed again and put it back in place and solder it again. And as you can see, the result is pretty good. You can't really tell this thing's been replaced at all. There's a slightly wider gap down there, but that's not a problem. I put those back on. I took the, if you recall, these elastics were gone. There was one side that had elastic, the other side had some cotton string. I used the cotton string instead. And then I started on these capacitors on top here. And I take advantage of doing all of them. Basically, these are, they're around the output transformer, obviously. So they tend to have something to do with the feedback circuits, with the audio tapering. So I do all these and then I go onto the schematic and I paint in what I've done, what I've checked. I do check the continuity and the resistances and everything else. These things all measure fine, so that's not a problem. And the result is this. I use these capacitors, which this black mark here shows the foil side. So I do go into that detail and make sure I've got the foil side done. So, you know, you look at this thing before and after, it's pretty obvious what's been done. It looks a lot neater, and also the base there has been cleaned up as well. Then we get onto the inside, and this thing is quite interesting because there are not that many capacitors on the inside. A lot of them, as you can see, are over here. If we look at this from this end, we've got one still hanging down there, but that's in the radio section, so I haven't bothered with that yet. But if we look at this, all of them have been done really. As I said, not that many. Just the yellow ones there. There's a black one down at the bottom, which I mentioned was going to be a nightmare, and it proved true. But before I go on to that, there's a 47 microfarad electrolytic. That's the cathode bypass capacitor on the power tube. Replaced that with, it was a 50, I replaced that with 47. Now the one at the bottom there is interesting. It's actually a shielded capacitor. And this is what this thing looks like. Now it's got 3 wires. You've got the one on this side, normal. This thing says 0.01 microfarad at 250 volts. And here you've got 2 wires. Now the first time I saw one of these I got stumped, so I did some research, and then I actually did a video on how to do one of these. There's the other wire. So the capacitors between these two wires. And this is actually connected to a shield that's around the outside. Now the whole point of this is because of where it is on the circuit, it's pretty sensitive to noise. So if you connect this to ground, you're shielding it from noise, and it works quite well. And the way I go about doing that is I just take a normal capacitor, 10 microfarads in this case, 10 nanofarads in this case, and I get some aluminium foil, just the normal stuff that you can buy quite cheaply, and then wrap it around it. And the reason I've put the heat shrink on the legs is so that you don't short anything. You heat shrink it properly first, then put this all the way around. I actually go beyond the ends of the capacitor, because if this thing's picking up noise on the capacitor, it'll just as easily pick up noise on the wires leading to it. And I end up with basically an old-fashioned suite. That's what it looks like, all wrapped up. And then I wrap some wire around it, which makes contact with the shield, and that becomes my third pin, or my third leg coming out. Again, the wonders of heat shrinking. Put that on there and label it so that in the future I know what the hell that is. And what I've got here is a 10 nanofarad 630 volt shielded capacitor, which replaced the one that was in there, and it seems to have worked pretty well. Right, we've got the schematic here with a little bit of green and red painted in here. This shows what we've checked. And what we can see here, we've got the power supply, which I've discussed before a little bit. The transformer's working, we know that, so I can paint that in. I've selected the 240 volt input there. Okay, then this signal comes out of the selenium rectifier, which I haven't changed at all yet, and it comes to this point here. Now that point there, that's the first 50 microfarad capacitor. I replaced it with one of those inside the restuffed filter can. That's one of them. Signal comes from here, goes up there to there, into the output transformer primary. It goes then through here and feeds the anode of the EL84 the way it was told to do. And the signal, or the voltage, also comes through part of this winding here on the output transformer. This is sort of a humbucking winding, if you want to call it that. Comes through there, through a resistor, to the second filter can, which is the second one inside that restuffed can. And if this one is called B+, I'll call this one B1+. Those are the two first B+ voltages supplied and filtered. Now, what else have we got here? Well, we've got basically what we're looking at here is the entire audio section. By audio section, I mean the preamp section and the power amp section. And if we look at it more closely, we'll be able to follow the signal through, and I'll explain to you that in a second. What I show here in red are all the components that I've had to replace, and they are only capacitors. All of them were those paper caps, with one exception. This guy over here, which is the electrolytic cathode bypass capacitor. Resistors proved to be incredibly accurate, and I'm talking less than 1% in some cases. It's unbelievable. One other thing I need to mention is this capacitor here, for example. You don't see it painted in. That's because it was a polystyrene. Those things hold out very well. I was able to measure it, absolutely out of circuit, and it's in perfect condition. One other guy that's a mystery cap is this guy over here. And this is an important one because this is the one that takes your external audio, in fact all your audio, and feeds it to the volume pot, which is over here. I couldn't reach that guy because this thing is sitting on the upper section of the switch assembly, and I just cannot get to it. I can't see practically anything. What I can see, which is promising, is that it looks like one of these as opposed to one of these, right? If it's the same as that one there, then I'm praying that it is in the same condition as that one there, because that one measured absolutely fine. So I'm hoping this guy is the same, because I cannot get to it, and I'm not going to disassemble the entire switch assembly to get there. I could probably just sort of cut it out and put it over the top, but I'm going to trust it for now. We'll see what happens when we do the test. So as you can see, you get your signal coming in here, either from the gramophone or from the tape. If you put it in through the gramophone, it goes through a 47K resistor here to this point, which is where the tape input would go. That then goes to an audio selector switch. That switch selects whether you're going to hear something from the outside, in other words, gramophone or tape, or whether you're going to hear one of your radio stations from one of the radio bands coming from this end, which we won't worry about for now. From this point, you've also got a 2.2 meg resistor, 47 to ground, and this forms a potential divider which provides your record out signal. So in this particular case, on that DIN socket, you've got tape in and tape out. Anyway, carry on. Going through this mystery cap, we pray, we pray, we pray. We meet our first tone shaping element here. I'm not sure which one this is. I can hardly read that. But it's, it's either bass or treble or intimate or jazz. It doesn't matter. I'm not going to go into that sort of detail on this schematic reading, but it does your first tone shaping because it either allows this capacitor to be in place. Actually quite easy. You got 10 microfarads, 10 nanofarads here, right? If this switch is open, the way it's shown here, then everything gets channeled through 330 picofarads. Now that gets rid of a lot of your bass, because bass frequencies don't like going through such small capacitors, right? So this will get rid of your bass. Now if you hit that one there, boom, you short it, you've suddenly got your signal going through a 10 nanofarad path as opposed to 0.33 nanofarad path, okay? So that means that more bass gets through. So my guess is this is the bass switch. So anyway, signal gets through here. It goes to the top of the volume pot. The top of the volume pot meets a lot of other stuff like this here. There's another tap or tap off, or whatever you want to call it, off the volume pot, which is used for tone shaping or pseudo loudness control, if you want to call it that. And that allows you to, again, reshape some of mostly how the treble frequencies, the high frequencies, get treated in this circuit. It also meets up with, oh no, we'll get to that in a second. Anyway, that's the top of the volume pot. The bottom of the volume pot goes to ground? No, it doesn't. It goes through a 220 ohm resistor to ground, which gives you a level here where you can add negative feedback. Now, where do you get that negative feedback? You get it from your output, from your speaker output. Your speaker connection goes 1 to ground, and this is your speaker connection that goes through this circuit here, and these resistors, and these capacitors, and these tone shaping switches. It's quite a cocktail, and it feeds that signal, boom, to there. So whatever gets added there is actually being subtracted from your signal, because this is an inverted signal. It's negative feedback, and it's also global negative feedback, because the signal that is getting amplified is the one that's taken off the wiper that goes from there, up there, in there, out that way, amplified through your speakers, and goes back to that point. So this is being subtracted globally from the preamp input all the way to the speaker output. You've got local feedback here, but that's a different story. So this looks at your entire output and shapes it by changing the way the input to your preamp looks, okay? A lot of shaping going on here, a lot of tonal cocktailing happens here. And the whole point is to get those different mellow levels of mellow sound that you're going to get from there. You know, bass, treble, jazz, intimate, whatever that means. Anyway, signal then comes out here from the pot. It goes across into and through that sneaky bugger, the one that is shielded, hidden at the bottom, goes in here into the grid of this triode. Now this tube has got 3 diodes and a triode. In this particular circuit we only use a triode. The diodes are used for the radio function. We won't look at that for now, but this tube is sufficiently energized with a B plus over here and ground on the cathode to send our signal in here. It's got a grid leak grid bias. It's grid leak bias, so it's biased by the electrons flowing through this 10 mega ohm resistor, which is very, very high. So very few electrons create a pretty decent voltage, biases this tube, and then that gets amplified, comes out here through there, and then it goes to this point where it goes through the audio, gets taken off through here to the grid circuit of the EL84, which is the power tube. And these things down here, that there and that there, are just the bias conditions for that anode. Now the signal is here, it goes through there, grid leak resistor 820K, that's normal, and then another T connection here, which gives you the opportunity to again mess around with the tone of the audio by either putting a resistor capacitor to ground or lifting it. If you put a resistor capacitor to ground, in other words, if you close that connection there, you are going to allow high frequencies to escape to ground as opposed to going into where they're supposed to go to, which is the grid of the tube to get amplified. So you can actually reduce the treble content that this tube is going to amplify because some of it escapes. Okay, this tube then receives a signal, amplifies it, and drives that amplified signal across the primary of this transformer, which then gets induced on the secondary, which then gets sent to the speakers, which then creates the feedback, which then affects the signal, which then goes to the preamp. You get the idea? Yeah, okay, good. Now there are a couple of things here. This one here, this resistor, this capacitor here, 6800 picofarad. This thing allows some of the treble frequencies to leak to ground purposely, so that this thing doesn't oscillate at high frequencies, like in the hundreds of kilohertz or more, and create some damage. You won't hear it, but it could actually damage the circuit. So this thing leaks some of that to ground, stops oscillations basically. And then it also allows a point where, from this point here, which is where your audio is, right? It allows that audio to then go and excite the electrostatic tweeters, right? So electrostatic tweeters, one side's connected to ground. See that? The other one is energized by high voltage coming from through this 47K resistor that comes from your B1 plus. So this thing has got high voltage across its plates, but it's sitting there with nothing. Suddenly some music comes along, and the high frequencies of that music escape through this capacitor. The low frequencies don't, they just go down here. But the high frequencies actually get through, and they get put across as an audio signal, as an AC signal across this static condition of DC voltage. And what happens there is that the plate starts vibrating in harmony with that music, and that's how your electrostatic tweeters produce high frequency audio content. Okay, so basically that is it. And if we look at this, we're starting to get sort of a nicely painted picture, and I'm possibly not going to paint every single line, because as I said, this radio is working, so I've got a few things to check obviously, but I might not have to check, I might not have to troubleshoot every single wire on here as I've done here, right? I've done this more for the exercise purpose than anything else, but we'll see how this thing develops as we go along. What I want to do now is I want to send a signal into the gramophone input, boom, into there. And we are going to listen to it on the speaker, or possibly through a dummy load, and then watch it on the oscilloscope and see what sort of signal we're getting through. See if it's a clean signal, see how what sort of amplitude we're getting, see if we're getting into distortion, etc, etc, etc. Enough blabbing, let's get going. All right, we've got everything set up. I've got the signal generator producing a 1 kilohertz signal at 100 millivolts RMS. It's active, volume control to sort of middle medium. I'm going to plug this into the gramophone input, make sure I get it right. Gramophone input, okay, gramophone input selected here. and this is on already, so I need to put this on music. I need to be careful. I've got this thing on the dim bulb tester. The speaker is coming to this speaker here. Speaker selected. I can put it on dummy load if I push that down. Speaker selected. I've got that output being monitored by channel 3 of the scope, so we'll be able to see what that looks like. And I've got, let's put just the one lamp on. One lamp is on, limit's on. Let's hit it. Oh, it was a bit of an anticlimax. That thing just sort of glowed a little bit and then went off. I've got the dial lamp on that I can see. It's 219 volts, drawing 70 milliamps. So that 40 watt bulb is limiting the current quite a lot. Now if I put the volume up, yep, I can hear it and I can see it. Okay, let me show you the scope. I'll put this on dummy load so we don't have to listen to it. Beautiful. Very nice sine wave, and I've got the volume on max and I'm reading 2.9 volts RMS. No distortion yet. I'm not sure what sort of power we can expect from there, but what I'm going to do is I'm going to give it another light bulb. It's drawing 90 milliamps. Another light bulb drawing 110 milliamps. Another light bulb drawing 110 milliamps, 226 volts. So there's very little restriction at the moment, or rather there's quite a bit of restrictions, 140 watt light bulb, but there's very little current being drawn. So the voltage the radio is seeing at the moment is 226. Now remember, I've set that to 240, so we've still got a bit of leeway. And as you can see, the voltage has gone up to 3.16. I'm still getting no distortion. What I'm going to do is I'm going to put in the final light bulb. So now the radio is seeing 228. And we've got 3.17 volts. Beautiful, no noise. I did clean the pots with contact cleaner. I'm going to increase this to 200 millivolts. And now we'll see when it starts clipping, and it should. Well, yeah, it's sort of clipping there. Actually, I think we can probably still fit it in there. Yeah, that's clipping there. About there. 3.6 volts RMS before it starts clipping. And if I go crazy, it just does that. Not good. So that's our clean sine wave. If I bring it down a bit more, that is a beautiful sine wave. That's beauty. That's a beauty. Now if I go and at the moment I've got music, if I put speech, it does affect the level. If I leave it on music, it's allowing all the bass through, I think it is. Now if I go into, what is that, intimate, it does something to the high frequencies, it seems. If I put jazz, it allows the high frequencies through. So you see those are the switches I'm messing with, and it is really affecting the audio level. So that's looking good. Everything's looking good. Let me drop that a bit more and put that up. Always looks good to see that kind of response coming out of the amplifier. So this is where we are. We haven't actually got a radio done yet. We've got a tube power amplifier restored and working and tested, and because I've only got the two tubes in, as you may have noticed. This is the preamp tube and the power tube. So the next step is to follow my normal logical order, which is go back in the circuit. I'm going to check the AM section, change any components, repair any components that are required there, possibly do an alignment, and then go to the FM, check the components, and possibly do an alignment. But that is work for another video. For now, I think I'm going to stop here. This is a good place to stop. I'm going to test this thing with some music going through, music coming into the gramophone input, probably through the just the normal MP3 audio source. Remember, this is mono, so if you put in audio at the back, you've got to convert it from stereo to mono, otherwise it sounds kind of weird. And put this on speakers to see what this sounds like, let it play for a while, because a lot of these components need a bit of working in, I guess, and to get to the optimum condition. But in the meantime, that's what I'll be following on with. It's the radio section, the AM section, the 2 AM bands. And when I've got some more of that done, I'll report back to you. So that's it for now, and if you've enjoyed the video, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Links are in the description below and at the end of the video. And I want to thank you for coming along for this journey. Thanks for watching. Bye for now, and stay safe.